each blog has multiple articles, blog entries, and each blog entry has one or more, or sorry, I should say 0 or more comments, right? Depending on how popular you are. And then with each blog entry, you have tags associated, like either MongoDB or PHP or mapping or things like that in my example. So if you store this system in a relational database, you end up with how many tables? Anybody wants to guess? Well, it's quite simple because you just count the amount of boxes, right? It's 5 of them. There's a cable there, yes. And you'd either end up breaking the projector or my laptop, and neither of them is a good thing. So yes, in a relational database, you'd store this in 5 different tables. Now, how would you store this in MongoDB? Which collections would you store this in, right? It's a good question, and I'll give you the answer this time. You do something like this, right? You have 3 collections, one containing all user information. Because usually associated with a blog post, you only really need its name and maybe email address. Yeah. The blog collection itself is also a separate collection here, containing the name of the blog and the URL. But the other 3 tables that we had, the blog entries, including all the comments and the tags, I've now put in one collection using embedded documents. We store an array with the tags and an array with the comments, and each comment then has multiple fields again. It will have a comment, the comment date, and a comment author. So we end up with 3 collections. What could be alternatives? Because this is something, if you design a relational database schema, and you do this correctly following the theory, there can only be one solution, right? Yes? Right, so one of the issues with this is if I have a tag and I want to change the name of this tag to a different name, we have to update more documents. So yes, you can create a tags collection and use an ID field. But you need to consider for yourself, how often do you actually create the name of a tag? Is this something you do once every minute? Or is this something you do once every 3 months? And I think the answer would most likely be every 3 months compared to every minute, right? Right. So yeah, this is a trade-off that you need to make. And I think in most cases, tags, the values don't really change so much. So I'm okay with them storing them as an array in my document. For other things like user values, like for example their email addresses or how often they have logged in or what their passwords are, that is probably information I don't want to store in my blog entry because it ends up changing quite a bit, right? And also I don't want to have to duplicate the data. But tags themselves, whether you'd store a number or a small string, data-wise, data size-wise, it doesn't actually matter so much. And you have the possibility to find documents very easily by tag without having to make 2 queries. MongoDB doesn't do joins, right? So if I want to find all the entries all the blog entries that are related to MongoDB, what I would have to do if it wasn't part of this document, so I would have to make a query to the tags collection to find its ID of its value. And then secondly, I have to make another query to find all documents where the tags ID matches. In any case, tags will still be an array, right? So yeah, this is a trade-off.
I have another question.
Yeah?
Because on these cases, the blog and the blog is a list of articles, but
yeah?
you mentioned website with content.
Yep. So it's actually slides I've removed from this presentation, how to store trees, because it's quite a complex subject. And there are multiple ways to doing this. One of them is storing the tree in one document in MongoDB. But that is not very scalable. It makes it very difficult to do updates on four levels deep in your tree. Also, you will likely run into the maximum document size limitation of 16 megabytes. If you have any sort of larger tree, then yeah, you just cannot do that. It's not performant enough. So what you will see for storing trees in MongoDB, you will see the same thing as happening in relational databases, where I know Easy Publish has like this path way of storing information about who are its ancestors. In MongoDB, you could do something similar with all the modifications to make, like finding the parents of documents easy. And I think Easy Publish also stores its parent ID. Right. Yep. Yep, and that is definitely true. So storing trees in MongoDB, you're going to run into the same problems as in a relational database. Because this database is not created for storing trees. It's created for storing documents. So if you want to store trees efficiently, you'd store that in a graph database that is optimized for doing so. For example, Neo4j. Which of course means you end up having multiple databases again. But
And adding this kind of feature is question also for policies. For example, in the world, if you want to have some limitation, depending on the time,
yeah.
and use all the features and depending on the time, you can see on what are. It's always something difficult to
Absolutely.
document oriented.
Yeah, there's similar issues, right? And it depends on the. So this is a bit of a non-answer. If people ask me how would you design this data schema in MongoDB, and I can never give an answer to that because I don't know how you talk to a database. I don't know what your update frequency is, what sort of updates you do, what sort of queries you run. And you need this information to be able to design a proper schema. So let me continue a little bit, and at the end, if there's still more questions, I'm happy to answer them. All right, so how do you think about designing the schema? In a relational database, there's theory, right? How you do the proper normalization. There's only one correct way of doing this. But in MongoDB, you would look at what are read-write ratios. What sort of updates am I doing? Sorry. What type of queries am I doing? If I don't have to think about certain data that is older anymore, might be an influencing point on how you design your data. But you also need to consider that there's no joins. And there's also no transactions that go over more than one document. So only updates to a certain document are atomic. And with those constraints in mind, you need to think about how to store data. So I have another example here, right? Is my microphone working? I hear it differently than it used to be. Since it stopped. Well, turned off, so that's probably wrong. Okay, let's see whether it's the battery, and I'll just switch the battery in a moment if this happens again. All right, so different relations you can store in different ways. You have, well, one-to-many relations, which is a very common thing to do. So yeah, let me just show you an example. So what I have here as an example, how I could store, again, blog entries. So I have the name, or so that's the subject, there's a date, there's a bunch of comments, there's a bunch of views. And the views are really basically, okay, it's definitely turning itself off. All right, so in this case, I've decided to store in each entry, I've decided to store both the comments and the views. So the views is something that gets updated every single time a person views this entry. The comments, of course, is only updated whenever somebody makes a comment. Now, there's a big distinction between those two arrays. On my blog, the most amount of comments I've been getting is about 15. That's not a lot. How many views are some of the articles getting is something totally different. It's in the thousands or in the 10,000 sometimes. Which means that this views array keeps getting larger and larger and larger, up to the point where you might actually run into the document limitation of 16 megabytes. With the comments, I don't really have that problem because it's so little text that it doesn't really matter to me. But there's another problem with this. Every time I would do a query for a specific entry, I'm also updating this document. So the read-write ratio is 1-to-1 almost, right? And that is not a good workload for MongoDB. You want to separate your heavy reads from your heavy writes to documents. For the comments, as I said, it doesn't matter, because at most it's going to be 10. I mean, that's so little that it doesn't matter. But for the views, it's not a good pattern to do. So, as an alternative, what you can do is separate out your views into a separate collection. Storing it like this, for example. So I still have the comments in here, but I have the views in a different collection. So now I'm storing in this collection the article IDs 4, which points back to the ID here. The IDs, of course, are different, but this is an example. And I store the time as well as the IP address. But I'm not storing those with each article anymore. Meaning that I can write into the views collection as much as I want. It's a really fast operation because the only thing I'm doing there is adding new documents, which is a lot faster than updating documents. Another thing is that if I keep adding information into a document, the document grows. And when you initially insert a document into MongoDB, it will save space for it on disk, with a little bit of padding at the end. Of course, if you start adding data to it, it runs out of its allocated space, and the moment that happens, it needs to move the whole document on disk. And that is, of course, a slow operation. So you want to avoid that. And you avoid that by not having arrays that are unbound in its size. Views is sort of unbound. Theoretically, comments are also unbound. But I really want always to show my comments with each document. So for me, it's beneficial to have to do only one query to get the blog article and all of its comments. Whereas this is not a query I ever want to do with my views, right? I'm really not interested in all the 10,000 entries that end up in a views array when I'm showing an article. What I could sometimes be interested in is the amount of views for a specific blog article. So in that case, what you can do is write every single entry into a views collection, but still keep a count in each document. So what I could do is have an extra field here that says view count, which is then the amount of views that actually have happened. And doing an in-place update of a number isn't really much of a problem. Because anytime you view a document is being loaded into memory, which means doing an update of a specific field in this document is also an in-memory operation, which makes it really fast to do. So yeah, this is how you think a little bit on how you do queries and updates. And the ratio between them depends very much on how you design your schema. Alternatively, or another good point about storing this view collection in a different collection is that I can now run specific queries against this view collection very easily. Like I can find out all the times that a specific IP address has visited any article. Whereas in this case, when I run a query like this, it makes it really difficult to run a query against, right? Because you'd get the same document only once. If a specific IP address would view an article multiple times, then you'd only get one result. Because this views array is actually part of the document. So even if the IP address 101 is in here 4 or 5 times, you'd only get this document back once, so you cannot actually do this calculation even. Make sense? All right, so a few other tips and hints about storing data. Say, for example, you have a system where you want to store temperature information for loads and loads of sensors. And each document here is a specific sensor. So what I've been doing here is, the ID of the sensor is 42, and then I store the points. The points is the data points it collects. So we have the key, which is the Unix timestamp, and the value. So basically says at this time, the temperature was 17.3 degrees Celsius, or Fahrenheit, doesn't really matter, it's a number here. But this makes it really difficult to do queries against. You cannot easily find out between which timestamps there was a certain temperature, because you can only do queries against field names. But in this case, the field name is actually a value. It's a value, and you cannot know upfront which values exist in the system, because not every sensor will have a time point for every single second. In XML, this is very similar to having tags that don't have a defined key name. The same thing in MongoDB. Storing data where you cannot document the key name is usually a bad design decision. Of course, there's always going to be exceptions to this rule, but in general, make sure that your keys you can document. So instead, you would store it like this, right? The time index is now a value of the TS, which stands for timestamp, key. And the same thing, the temperature now has the key temperature and the value 17.3 again. So this is something to take into consideration. All right, so we're going to do an exercise, and I've spoken too much about beer, so we're going to be talking about my next favorite beverage, which is whiskey. A bottle of whiskey showing up on my table is probably a bad idea. Although I've seen people giving presentations at 9 in the morning sipping whiskey, but that is a bit too much hardcore for me. All right, so what we're going to do now is design a schema for storing some information. And as I said, there's no one good solution for this, so I'll be asking you later how you have stored this. So this is something we don't really do, creating schemas in the database. If you have pen and paper, that'd probably be a better thing to do. And I know your attendee bags did get a notebook in there, but I don't see any on the table, so you'll have to use a text editor to actually do this. So what we want to do is, we want to store information about whiskeys. Each whiskey distillery often has many different whiskeys, right? So what we want to do is we create a schema that stores information about whiskeys, about the distilleries, and about the whiskeys that they make. So information to store is for each distillery, you want to know the country where they're in, the region, which is an optional thing. Regional, if you are into whiskey, then you know that in Scotland there's multiple whiskey regions. If you don't want to think about that, forget about this field. The name of the distillery and the year it opened. For each whiskey, we want to store the name, the age, the strength, and optionally the vintage. Vintage meaning it got distilled in 1999 or something like that. And also we need to be able to store the relation between the distilleries and their whiskeys. So you understand what sort of schema or what data I want to store. So what I want you to do is create a schema, which collections and which fields are going to be stored in each of those collections. Does that make sense? You understand what I'm asking here? All right. So I'll give you 5 to 10 minutes to come up with a schema, and then we'll discuss the different possibilities that are actually possible to do. All right, let's say, go. If there's questions, of course, I'm here to answer them. I sort of really want to open a beer, but that's a bit improper to giving a tutorial. Maybe over lunch. Who, by the way, delivered this beer can on my table? Thank you, Norman.
So in your database? I don't know.
No, I don't. No, well, you have the database. Look it up yourself.
We don't know how to do wildcard search.
Wildcard search. Ah, that's a good question, actually. It is possible. I'll ask it after this exercise, and I'll show you how to do wildcard searches. So you have two collections. You have a collection that's called distillery, and a collection called whiskey. For each whiskey, I'm storing the name, the age, and the strength, as an example here. As an example, I'm taking Glenfiddich 15, because that's what I had on the shelf, trying. All right, so the collection distillery contains the name, the country, the region, the opening year, and then an array of the whiskeys that it has. So who designed it like this? Show your hands. One. Why did you do it this way?
Well, it was one of the possibilities.
All right, it's one of the possibilities. So it depends a little bit on what kind of queries you're going to ask, right? If you're going to ask, give me all the whiskeys for a specific distillery, then this is not a good schema. You know why? Because you have to do a query for the distillery collection first, to figure out which whiskies they have, and then have to do a second query to find out more information about them. So if this is a query that you do a lot, finding information about all the whiskies in a distillery, this is not a good solution. However, if you just want a list of the whiskies it has, and then clicking down to the next page for more information, this works. So what is the alternative here? Well, an alternative is to store the distillery information with each whiskey. So when I now want to find all the whiskies of a specific distillery, I can do one query in the whiskey collection and search for every document where distillery is Glenfiddich. And I have immediately all the information in there for all of the whiskies for this distillery. Who had it this way? Okay, so what other solutions did people come up with? Okay, one more time. Yeah. Okay, so distillery with all the, do I have that? No, I don't have that example here. So yes, that is another solution, right? But that makes it very difficult to run queries for a specific whiskey. Because if you would want to find all the information, correct, if you want to find the information for, say, the Glenfiddich 15, you do the query against, for example, whiskies.name, being Glenfiddich 15. But what you get back from this query is information for one distillery and all of its whiskies. Okay, I see question marks showing up on people's faces. So I will show you this, what I mean by it. Temporary file name. Yeah, and once in a while when I do this, it says this file already exists, which is really quite annoying. All right, so we have this, right? No, they're not. I will copy this one in here. Of course, we don't need this anymore. Of course, there's multiple whiskies that I have, right? The 50.3, by the way, is a made-up number. It's 46 for all of them. But this would be the schema that you've came up with, right? So if I do a query to want to find information about a specific whiskey, say the Glenfiddich 15, the query that I have to run to find this is db, sorry, let's call the collection distilleries. Distilleries. I still misspelled that, I know that. dot find, and I would have to do whiskies dot name. So spelling Glenfiddich is very difficult. Auto-completion for the win. So if I would run a query like this, the result of this is going to be this whole document. You don't get the information for a specific whiskey. So in your script, you then have to loop over the whiskies field and find the correct document out of that again. So this is why you wouldn't store it like this. Unless the only thing you really want to do is show information for all the whiskies with one distillery. And that might, of course, be a good requirement. That, of course, is an answer you can do with the schema, because you would be able to do db.distilleries.find like I have here, and then if I'm only interested in the name of the distillery, then I can use a projection here, right? I can use a projection name 1. Or if I'm also interested in the country, then I do something like this. So that what you don't get the whiskies returned then. But what you cannot do is return only one of those subdocuments. At the moment it's not possible. It's likely that it will be possible in the future, but it isn't at the moment. So yeah, those are the 3 options. There's a 4th solution. Yes, you can store IDs. Yes, that is another solution. So which one should I pick? It depends. That is the only correct answer, yes. It depends very much on what questions I'm going to be asking. So that is the advice that I have here. I think what I probably would have done is I would store it this way. Because this is also allows me to create whiskies atomically, right? If I insert a new whiskey, then this is an atomic operation for one document. If I would, if I would store it like this, and I add a new whiskey to it, I will have to update the whiskey collection by inserting a new document, but I will also have to update the distillery collection to add the new whiskey here. And because this happens in 2 different collections, you cannot have a transaction around this, meaning that you cannot do this as an atomic operation. Now, of course, this doesn't really matter in this case, right? I mean, I can add a whiskey into the whiskey collection first, and then a split second later, I can add the name to this array, meaning that it would only be visible after the 2nd operation. So in most cases, transactions aren't actually that important in this case. Of course, in other cases it is, but for this specific requirement, it wouldn't be very important. I mean, it doesn't really matter that the whiskey shows up a split second later because you hadn't linked it to the distillery yet, right? It's the same thing like you're doing an insert for a new comment on a blog post. The user that has inserted the post or the comment would like to see it immediately. But for the rest of the world, if it takes a few seconds, it doesn't really matter so much, right? I mean, it's the same thing with Facebook post comments. That is not a transaction either. I mean, they don't really care if some other user see this post update a few seconds later or even a few minutes later, because it's not important. Of course, this totally depends on the application, right? All right, so that was the distillery thing. So let's have a look at many-to-many relations as well. So products, for example, can be in many categories, and a category can have many products. Like if you have a toy shop, say all the elephants, all the plush blue and pink elephants that you have, right? They're all toys. But they're also part of the category elephants, for example. So each elephant is part of multiple categories, and a category can, of course, have multiple products. So let's have a look at that, how we can store things like that. So I have a, not a distillery called products, a collection called products, and has blue elephants and pink elephants in them. And the blue elephant is part of the category IDs 4 and 7, which is toys and everything blue. And the pink one is toys and everything pink. But I'm also storing for each category which products belong to this category, which for toys is 10 and 11, which is the blue and the pink elephant, and of course for the specific colors, it's only one of them. Doing queries against a schema actually works really well. finding all the categories for a given product, you can do a query on categories and find out where the product ID is 11. Say, what is slightly interesting here, what I'm doing here? I'm doing a find on a scalar value, but it's actually stored as an array. And this is actually possible to do. If you do a scalar test for a specific field, and that field is actually an array, it will try to match against each of the array elements, which is really quite powerful to do. So in this case, I can find all the categories for a specific product by knowing its product ID, and I can do a query on it, and I get the category names in here. We'll get both 4 and 8 back, because this matches, this product ID's criterion matches with both this one as well as this one. Doing a query for all the products for a given category, for toys, I do a search in a products collection, and because they all have the category IDs embedded in here, I can do this with one query as well. However, if I have to do an update, I'll have to do that in 2 collections, so that is no longer an atomic operation. So this is one alternative. What are other possibilities here to do? It's fairly simple. You store the link only in one collection, right? So when I'm doing it like this, only storing the products with each category, which means that if I have a product ID, I can very easily list, sorry, I'm saying this the wrong way around. Finding all the categories for a specific product is now more difficult, right? Because 2 queries have to be made. You have to make a query against products to figure out which categories belong to it, and then you have to do a second query to figure out the names of those categories. Whereas the other way around, it's like finding all products for a given category is still a simple operation, because I can do the query against products and figure out which category these are linked to the products, and then show them in one go. So what is an observation here? Some of you might notice this. What I'm doing here, I'm storing the relation information on the other side, how you would do it in a relational database. Like the foreign keys are now on the other side, right? Because usually what you would do is for each category, so for each product, how do I say this? Well, of course, the relational database doesn't actually allow you to store arrays of values in the first place. So you would have to store. Oh, you can't actually do that. Huh. Relational databases are so limiting. Sorry? You need 3 tables for many-to-many relation. You're right. Yeah. You need 3 tables to do this. Yeah. Yeah, well, I won't say that the IDs that are part of NoSQL databases are new IDs. They're just implemented in a different way, right?
Yeah, but when you create a new record, you need to create a new record in different collection. Mm-hmm. So to avoid corruption of data, do you have an transaction mechanism to roll back something like that?
No. There's no transaction mechanism in there. Yeah, your code needs to do this. So that means your application needs to be a bit more intelligent about this. Yes, you need to think about rollback as well, which is a bit annoying. You need to do, yes. So transactions is something that we don't have in MongoDB because of scalability. Doing transactions where you have multiple collections living on multiple machines, you can create transactions for that, but that basically means that you have so many things you need to update on different machines, which makes it much more difficult and much slower to do as an operation. So we've made this trade-off saying, at the moment we don't do transactions. That doesn't mean that we might not come up with a clever solution in the future to make this work better, but at the moment it's not there yet. And I know there are some ideas going around this, but I can't talk about it too much because it's not been finalized yet. Right, so the second alternative, of course, is store the product IDs with its category, right? Which one you pick, of course, depends on the situation. So another thing that comes here is back to the distilleries, where some of you have stored all the whiskies of a distillery with the distillery information itself. Whether you pick that solution or having the information stored separately depends on how you query and update again. And that's the only reason why you would change how you would store your data. So you really need to think up front how you're going to query and update and insert information before you can make a proper schema. So for embedding information in another structure, like storing all the whiskies with a distillery, you get a very simple data structure. But if you have to update this, it's more work to do so. Also, something I haven't touched on, that some distilleries have quite a lot of whiskies, and you might actually end up hitting the document size limit of 16 megabytes. Now, I have to say that 16 megabytes as a document limit sounds small, but it isn't. If I would take every article that I've written in the last 15 years, they're mostly text documents, of course. If you add them all up, how large do you think that would actually be? It is slightly more than a megabyte of text. And this is 800 articles. So 16 megabytes is actually quite a bit more than you think it is. Unless you start storing binary data in your documents, which you really shouldn't be doing directly. There's ways around this, but I'm not going to have the time to talk about GridFS, so look that up yourself. All right, quick exercise. A little bit more about the whiskies. So, tasting notes is something like a review for whiskies, right? If I have a glass of whiskey, I smell it and taste it, and I'll pick out different flavors, right? And multiple users would do the same kind of reviews for a whiskey. So I'd like you to design a schema that allows for user profiles, and a user profile is as simple as a name and a country. Let's not think about passwords at the moment. Of course, we still have the whiskies, which again have the name, the age, and let's ignore the distillery bit in there. And then each user can have tasting notes. So I will have different notes or different review for whiskey than other people have. So create me a schema to store this information. And again, ignore the distillery bit for this one. I'll say, go. I'll give you 7 minutes. 7 minutes makes it nicely rounded to 11:35. All right, questions so far from me? Okay, so that is a good question. You need to ask me how I'm going to use this information, right? Right? That's a good question. And all of you should have been asking those questions, so plus points for you. I don't have any prizes, unfortunately. But yes, I would have liked to hear more questions like, how am I going to store this information, or what do I want to do with it? So let's answer that I want to show on my profile page the latest whiskies that I've tasted.
So just a profile page on user view?
On my user view, yes.
That sounds like you have open all the possibilities or features. The best way is to have our collection and never connect them or make them somewhere. To be able to always leave them or fetch, carry them in single code.
Yes? Yeah, so the question is more, which queries would I run more, right? Would there be more views of a user's profile with the latest tasted whiskies? Or would there more views of seeing all the tasting notes for a specific whiskey? That's the distinction that you have to make.
But if you have two independent relations,
yes.
Tasting notes just add key for the whiskey, you can both.
Yes?
Start to filter on it. Don't filter on whiskey or user. So we need to use testing notes.
Sounds good to me. So yeah, again, there's of course multiple solutions. It's not 11:35 yet, so do you want me to continue explaining this, or do you want to try it more yourself? Who wants me to start explaining it? Who wants to continue trying it out themselves? And who's sleeping? All right, okay, I'll just explain it then. So one solution is doing it like this, right? We have a collection about all the whiskeys with all the information, and of course we can hook the distillery bit into that again, like in the previous scheme we have. We have information about its user, its name, and in this case the country, which England is perhaps not quite a country, depending on who you ask. The real name of the country is, of course, the United Kingdom of Great Britain and Northern Ireland. But that is way too much to type, so we'll go with England. We'll see whether Scotland will become its own country in 2 weeks. Interesting. It would be really annoying for whiskey, actually, because they won't be part of the EU immediately, right? So it makes it suddenly really difficult to import whiskey. So I'm against Scottish independence, but that is a selfish reason. So of course, yes. And then we have the collection tasting notes, right? Where you have the username, the whiskey name, and then the notes for it. And storing it like this, storing all the notes for a specific whiskey, or showing all the notes for a specific whiskey is really simple to do, because you can just query this collection. Also, showing all the tasting notes for a specific user is also simple, because you query this collection again. So that means that if I want to show information about a whiskey and all tasting notes belonging to the whiskey, there will be 2 queries. If I am going to show all the tasting notes for a specific user, I'm going to do 2 queries. And that might be a good solution. Use information you can probably cache a bit longer as well, if you think of it in your application. Because they don't, I mean, invalidating the cache information for a user is a simple problem to do. Because you know the moment a user updates its information, you get to invalidate its cache, right? So this is probably how I would start. What have other solutions been?
What do you think about replacing the username and whiskey name by IDs or unique IDs?
Okay, that's a good question. What do I think about replacing the username with its IDs instead? Well, I wouldn't do it. If a user has a unique key already, of course, a first name isn't a unique key, right? But a username often is. Like on Twitter, I'm Derick R, which is a unique identifier. So why invent another key for this? There's no reason for it. You have the links, but now I can make a link on username, right? Of course, Derick is a bad example here, but it could have been Derick R, which means it is a unique name. Would I store all the information with the nodes? Maybe I would store the full name as well, so I can show the full name for a user. And of course, if then a user updates its name, you would have to do an update in this collection, right, to update all those values. But you'd have the same thing. You wouldn't have that, of course, if you only store the IDs. But it means you'll have, if you for a whiskey want to show all the tasting notes and their usernames, you'd have to do 3 queries. Mm-hmm. Yeah, but you'd create an index on username and whiskey name, and but that makes very little difference than doing it on an integer. So yes, it takes up more data in your index, but search performance isn't really affected by that. But yeah, you end up having large index. That is certainly true. But as alternative point to that, you don't have to do queries if you just want to show usernames, right? But it's a good point you make there. It's depending on the use case, absolutely. Yeah. All right, so this would be another way of doing it, right? Anybody came up with it like this? Like storing all the notes with a specific user? Which you can do, but it makes it really difficult to show all the tasting notes for a specific whiskey. And you end up querying too much information. Or the latest one is also impossible to with this, yes. But I mean, if you would never want to show, if you only want to show the nodes for whiskeys that you have tried yourself and never want to share this information with anybody else, then this is a solution. All right, enough about schemas. Or another alternative, of course, store all the nodes with a specific whiskey. And this is something that I see many review sites do, right? They store this, well, the only view that I really get is all the nodes for a specific whiskey. They don't even have this user view in the first place. So if you have that, then this might work too. All right. Let's look at a few more queries that we can run against this schema. So if we would have the review stored with a whiskey, so if I want to add another review for another user, how would I do that? What kind of queries do I run? So that's what this slide is going to explain. So, for example, what you could do is you create a new review document, which has the same, not the same 5 fields. It has one less. It has likes not set when being added. That is for a specific reason, because there's another slide explaining that one. So you create this new nested document, right? So instead of Derick and a date, I'm using Michael and a date, and he thinks that there's no beat, but it's a bit fruity. And he rates it as 1. He doesn't like it. So to add a nested array into this array, you can do with a query quite easily. First, of course, we need to do a selection to find the correct whiskey. And then secondly, we use the push operator. And the push operator adds an element to an already existing array, or if the field doesn't exist yet, creates an array and then adds the element to this array. So what I'm saying here is I'm pushing another element to the array called nodes, and which has as a value this embedded document. So at the end, after I've run this query, you'd see that nodes now has 2 array elements. Once with a review that was already there, and secondly with a review I've just added. Does that make sense? So push is actually really quite handy. There's also an operation called add to set, which makes sure you don't have duplicates in your arrays, which is really handy if you have like an array of tags. Say you have the tags called PHP and MongoDB, and you push another MongoDB tag to the same document. If you use push, it will add the duplicate. If you use add to set, it will not store the duplicate, which is a easy way of optimization. This without you having to pull the document, making sure it's not already there, and then do the push, right? Because that is 2 queries. You read it, and then you updated it yourself. If you do that, then you have the chance that 2 application threads read a document. One of them, of course, both of them see that the MongoDB tag isn't there, and then the application decides that, well, we need to add it in one place, but because the second application thread also didn't see it was there, it ends up being added twice. Which is, of course, reading and writing, or doing a query in a document, doing something with the document and then storing it is not an atomic operation. Using push or add to set is an atomic operation. So if you can always use those atomic operations, because that means you don't have to do complicated transactions and things like that in your application yourself. The same thing is, if I have this document, I want to record a like somebody liked my review or disliked my review. So again, you can do a query for this, right? And this is a bit of a trick here, because imagine there's actually more nodes. And I want to update the review where the name is Glenfiddich, is the name of the whiskey, and username, which is incorrect, it should say nodes.username. You see what I mean, right? Because this is not a field that exists in the top level. It should be nodes.username. I will make a note and fix that. And then I do an increment on something that includes a $sign. So what this actually means is we pick top level field nodes, which is this one, and then we use the position of the find query. So in this case, that means the zeroed array element. And there we do likes and add 1 to this. So this is a position operator that only works in certain cases. It only works once in a field specification. The field specification here being nodes.position we have just found in the query, and then likes in there. Thanks very much. So this is something that you can do. You can find information in an embedded document and then update information in that embedded document that you have just found, which is kind of neat and handy to have. All right, so far I've spoken only about queries and insert, update. Well, I haven't spoken about delete queries, but they work the same as find queries, except that instead of returning the document, it will delete it from your database. So I can't really say much about that, of course. But there's also a concept like commands, and commands are things you run on the database. Commands often only return one document containing all the results in there. And this is something that is going to change very soon, because some commands are now also returning cursors like normal find queries do. And basically, insert, updates, deletes, and finds are now also commands on the database level. So this slide isn't very important anymore. But what I'm going to show you here is a specific command called aggregation that allows you to do lots of interesting aggregation queries with your data. So aggregation. That is, if there's no question about previous material. No? All right. Aggregation is really powerful. It is a replacement for MapReduce that we used to, well, we still have, but that we had in older MongoDB versions. Aggregation is a replacement for this, mostly because it's declared in JSON and it executes in C++. MapReduce jobs, you have to write JavaScript code that MongoDB has to parse and execute in a JavaScript engine, being magnitude slower than executing this in native C++ code. It's also very flexible, it's functional, and it's simple because it's much easier to debug than MapReduce jobs. And it's actually based on Unix pipes. So there's different operations you execute in order. So as an example, if you do PSAX, right? Let me just find a shell. If you run PSAX, you get often too much information, right? You get all the processes that you have. But you can filter that according to information. So you can do grep on, say, sbin. So this is an operation in your pipeline. In this case, you get less information, or we can make this even smaller by doing network, right? You get less information. So each operation you can do, another one could be sort that you could add to it. And then it sorts, of course, not very handily by the first column here, but you understand the point, right? Other operations are things like cut, where you cut out specific fields and things like that. So there's lots of operations that you all run in order. And that's exactly how the aggregation pipeline works as well. Right, so the pipeline operators are, there's a few more, but the basic ones are the following. There's match. Match is basically your find query. It accepts the same query language. It actually supports a little bit more than a normal find syntax. There's projects, and projects allows you to reshape how documents coming through the pipeline look like. There's group for doing group by queries. There's unwind, which is the opposite of a group. I'll have an example of that in a bit. Then, of course, there's sort, limit, and skip, like you'd have for normal queries as well. Okay, let's have a quick look at what match does. Again, this is our example data. This is information about bears, right? So the bear name is Aurora australis, and there's some comments, and you can see when I've drunk this, and what I thought of it, and where I had it, and which location exactly. And yeah, let's do some queries with this. Each of the examples that I have are a subset of this data, otherwise it's going to fit on my slides, so don't worry too much about that. So match does filtering on documents. It uses the existing query syntax, and it does not do geospatial operations because there's a specific pipeline operator for that as well. And it doesn't do where as a part of the query syntax. Don't worry too much about that if you don't know what this means. And most of you probably won't because I haven't explained it yet. Anyway, so what does match do? So on the on the left-hand side, I have 3 documents containing a subset of beer information. Like I have the beer name, the brewery name, and the beer type. So wit beer is a special type cider, even though technically, of course, not being a beer, is also something that I enjoy and is part of this database, so you have to deal with that. And there's a beer called a Eurolager, which is often not great beer. So if I have these 3 documents and I do a match against beer type being cider, it is basically find all the documents where the beer type is cider. So the only result out of there is this document. Hopefully that makes sense, right? So match is often the first operation you use in a pipeline, but it doesn't have to be. Sometimes, after you do a group by, you can do another match. Like you do a group by to count like the average rating for a beer type, and then I do another match to make sure that only the beer types with the highest average ratings are being matched. So match you can also run multiple times. You don't have to do it only as first operation. So you can also do matching with query operators. So you can say, instead of doing a scalar test, you can also do find me anything larger than 6% alcohol, for example. And in this case, it would only find this cider and not the other 2. But again, this is normal find queries. So project allows you to reshape documents. You can include or exclude or rename fields. You can inject computed fields. You can create sub-document fields and things like that. It is a reshaping operation. This doesn't fit on my slides. It fit earlier. Luckily, I can zoom in and out. Brilliant. So yeah, we have this beer, right? It's not a beer again, it's a cider. And the brewery name is Honey and Dollars. So what I wanted to do is to show you that from this document I have here, I'm only interested in those 2 fields, only in beer name and brewery name. So the projection says, show me the beer name and a brewery name. And I'm using for underscore ID, I'm using 0. Because by default, MongoDB will always include the underscore ID field in projections. So if I don't want that, which I don't want in this case, I need to set it to null, like don't include this. So the second one is doing some computed fields. So instead of showing beer name and brewery name as 2 different fields, I want to store this in such a way that the output, it has the beer name, and then between parentheses has the beer type. So for that, I'm also renaming brewery.country to country. So let me show you that one first. So this works as follows. The top level field names here are what the names are going to be in the resulting documents. And then the second bit here is like a specification. In this case, anything that starts with a $sign is a field specification. And it basically means the field country is going to have the value of the field brewery underscore country. Of course, that means that this brewery country is now going to be the name country here. The other one is beer itself. So the field beer is now going to be a computed field. It's going to be computed, sorry, difficult word, computed by concatenation of the beer name. Again, you see the field specification because there's a $sign in there, a space and the opening parenthesis, the beer type, and then closing parenthesis. And this, of course, creates a string, crazy goat, space, opening parenthesis, cider, closing parenthesis. So this is a computed fields. You can do other computed fields as well. You can do additions, multiplications, a whole lot of other things as well there. So it's not only concatenation of strings. Another thing you can do is reformat subdocuments. So, for example, information here about the brewery, there's a few different fields about it here, right? There's the brewery name and the brewery country. Say, for example, I want to have those both as subfields of the brewery field, and I can do that as well. So define the brewery as a new top-level field, create an embedded document where name and country are then both fields so values from a different field name. And then a resulting document is this subdocument where you have brewery with those two subfields. You can also do the other way around. You can pick out keys from a subdocument and store it in the top level document. My data set doesn't have an example for that, so I'm not showing that here, but you can also do it. All right, now comes the trickier ones, which is group. This works very similar to group by in a relational database, with some slight differences. So basically how you group by is you group by a field or a selection of fields. And you do that by specifying in the group operator, you specify the value of underscore ID. That's probably easier to show you. So what I'm, too big again. All right, so I have 4 beers here. You try to pronouncing those breweries. Good luck with that. I can do it because I'm Dutch and they're Dutch names, so that's simple. So what I want to do is I want to count how many beers there are for each brewery. So I'm going to group by the brewery because I want to collate information for each brewery here, right? So what I then do is I group by brewery name. And to group by a specific field, I need to set the underscore ID field of the resulting documents to brewery name. Which means that for each of those documents, it will see, oh, this is brewery name Heuge, or Brouwerij Heuge, which matches with the document I already didn't have the first time, right? So it will create a document where underscore ID is Brouwerij Heuge, and then it will add 1 to the field count. So the first time it sees this, it will create the document with underscore ID field Brouwerij Heuge, and it initializes count to 1. It does the same thing for Brouwerij de Dolle Brouwers. It actually says brewery, the crazy brewers. Then we have Bierbrouwerij de Koningshoeve, for which tree it will all create a document. Now for the last one, because there is already a document with the brewery name Brouwerij Heuge, it will not create a new document, but it will instead only do the other updates for the fields. So in this case, it says count sum 1. And that basically means for each time we find a document that has the same ID as a document I already have, we add 1. So the result of this is that we get 3 documents out of this. We get Brouwerij Heuge with 2 counts, because there's 2 beers, and then the other 2 will only have 1 beer. Does that make sense? If you want to group by more than 1 field, you can do that as well. You can create a compound key by using a embedded document here as key. And I think I have an example of that as well in a bit. So another thing that you can do here is you can collect distinct values, right? So what we can do here is, again, I want to contain all the beers that I have for a specific brewery. So I'm grouping again by brewery name, and then instead of counting how many beers there belong to them, I'm going to create a field called beers, where for each hit that I have for the specific brewery, I will call AutoSet with the value of beer name, which results in 2 documents, each for each brewery name, and that's 2. There's only Paulaner Groepen and Orchard Pig, which makes cider. And then in those return documents, instead of having a count value, I'm actually getting an array of all the different beers that belong there. And I'm calling it distinct values because I'm using add to set and not push. There are a few duplicate beers in the database that I have, for example. Does that make sense? So group by is a bit tricky to get your head around to, but it is actually quite powerful. And as an example here, I'm also grouping by compound key just to show you how that looks like. So instead of having 1 field name, I'm actually having an embedded document where I have 2 keys, country and type, which means a new document will be created for each of those combinations. So in this case, that will be cider and Wales, of which I have 3 documents. There's Perry and Wales, and Perry and England. So I'm grouping on both of those keys, meaning that I get 3 answers out of these 3 documents, and then the beers, of course, the ones that belong to each of the, not only the country, but the combination of country and type. Does that make sense? You remember this, because you'll need this in your exercise. So unwind does the opposite thing. If you have an array of values, it will create documents for each of those values in an array. My data set doesn't have that, so I created a example set that you cannot find in the database. So in this case, what I have an ID field called Denmark, and basically this is all the Danish beers that I've tasted. So when I call the operator called unwind, and I specify, it only works on arrays. So it only works if the beers field is an array containing different beers. And when running this operator, as a result in the pipeline are now documents for each of those values. So you see underscore ID Denmark, beers, Mochaccino, Messiah. An observation here is that underscore ID used to be unique, but suddenly it isn't. So the aggregation framework, because it doesn't return documents, it returns modified documents, underscore ID is not necessarily going to be unique. Only data stored in the database needs to have this unique underscore ID field. That's just how it works. And then we have sort, limit, and skip. And unlike normal query syntax, the order is important. I don't have to explain what sort does. It sorts, or limit, limits, or skip, skips, right? You can see those slides back later. But what is important is the order in which you do this. So if, as pipeline operators, you first do a limit and then do a sort, it basically only finds the first 4 documents and then sorts on those. So in this case, yeah, you get Old Enginal, Pilsner, Dumont, Blanc, and Roller, Amber Ale. So sometimes those names are kind of crazy. Of course, what you probably would want to do is do the sort first and then show you the first 4 documents. And in that case, you need to do the sort first and then the limit. Whereas in a normal query syntax with find, sort is always done first, skip is done second, and limit is done last. Whereas with the aggregation framework, the order depends on how you define the order, which is an important thing to know. All right, so as an aggregation example, I have an example here, and you're going to need some of this in the exercise that's going to follow up. So what I'm doing is I want to find 10 venues with the most distinct beers that I have. This is not a very simple thing, because you can see I use one match, 2 groups, a sort, and a limit. So the first match is to make sure that I'm only getting beers that actually have a venue associated with them. Every document is going to have this venue name field, but some of them are going to be empty. So the first match that I'm doing is I'm finding all the beers that actually have a venue set, because I'm checking for documents where venue name is not equal to null. So that's my match. So the second one, I'm going to group by venue name and beer. The reason why I'm doing that is because there are multiple instances of venues and beer sometimes. Like the local pub that I'm going to, I have the same beer multiple times. But I don't want to see that, because I want distinct values. And to get distinct values, you can just group by the columns that you want to have a distinct query on. So in relational database, this would basically say select distinct venue, venue underscore name, comma, beer underscore name, and then from table name. The second group by I'm going to do, because now we have only distinct entries for venue beer combinations, I'm going to do a group by on the venue name, which is now the field underscore ID dot venue, because the result of this is underscore ID field with venue as a subfield in there. And then I'm doing the count, so that for each entry for the venue name, I am now adding 1. So as you can see in this second group by, I'm not using the beer name anymore because I now already know it's distinct, so I don't care for it anymore. Fourth step is I'm sorting on the count descendingly, so I get the venues with the most amount of beers first, and then I'm limiting is this to 10. Does this make sense? So in PHP, you would create an array, and each operator also looks like an array. Looks like an array here because in JavaScript this is going to be an object with associative fields, right? Okay, there were questions here. I saw that.
Yeah. You have this group operator twice inside this
Yes.
operation. Can this also be done with sort and limit to do subsorts kind of thing?
Absolutely. Every operation that you see can be used multiple times.
Awesome. So that also means that I can use rewind, resort stuff inside of there, and then do it.
And then group.
Rewind and rewind.
Yeah. So yeah, you can do a rewind, sort, and group by again, so that you get in each document certain values sorted in the correct way.
So basically, this way I could actually get some atomic values from. For example, we have the user that has the notes and the rating of some kind of whiskey inside his profile,
Yep.
an array. So I can actually do a request to get, basically get the information on a single type of whiskey.
Yeah, absolutely. So in that case, you would do a match against the username, do a rewind on the notes, match against the notes for specific whiskey, because then that will return you all the different notes for a specific user, right? You do another match against a whiskey name, so you only get that one. And then, of course, you might want to group that back again, or not, depending on what you do. Yeah. One thing I have to say about this, if you want to use indexes with this, match needs to be the first one, because this is the only place an index can be used at the moment. But that's going to change as well. So that is sort of important. Don't do a group first, if you're then later going to filter out information. At each stage, you want to have as little information going through the pipeline, because that will be the fastest, which, of course, speaks for itself. All right, when I run this, I get the following results. So what is my most favorite pub? It's to use inside a tab. Kilburn Park is actually not a pub. It's the local area where I live. It's basically when I have drinks at home, and I don't want to have my address in this database, right? Then again, finding out where I live is not very difficult. So yeah, you can see by venue where I've had the most distinct beers in this case. All right, I know there's a lot of things to explain, and now it is time for you to run some queries. Okay, so the first thing I'd like you to do is with the database that you already have, or the collection that you already have with all the beers, I would want you to write a script that uses the aggregation framework to list the average rating score per beer type. So, to approach aggregation queries, you really do it step by step. So you would create a query or an aggregation pipeline operation thingy, and you do it exactly in the steps how you logically would do it. So the first thing you would do is create a pipeline with an operator that only lists the average rating score per beer type. When you notice that works, you continue with the other steps in the requirements. Does that make sense? Right. I'm pretty sure that you don't remember the syntax, so I'm going to copy the syntax here. Put it in file. Let's see whether I managed to hit the same one. No. Also, there. I love VI. It's great. As long as you don't fat finger. All right. I have to make this a bit smaller so that it fits. But all right. So this is how you run the aggregation framework. So the first statement to do is list the average rating score per beer type. So write a script to do that. Go. All beers will have a beer type. No, but you can get to ignore that. Not all beers have a rating associated, because I forgot that once. But do not worry about it. Correct. The average operator is clever enough to do that. So the average operator, which I haven't actually told you, is, anyone wants to guess what it is? It's AVG for average. Yes, I realize there's an extra array in the arrays in here, which is a bit annoying, but that's how it is. Checking what the end time is for me today. I think it's 12:45. $12:15. Oh, that's in 7 minutes. Well. Luckily, if you'd like, I have another hour and a half in the afternoon for me to continue. So it's up to you. If you'd like me to continue in the afternoon, I have the time to do so. Would you like that, Hans? Just after lunch. It's just the next slot. Because we have one speaker that fell out. I'm not sure which one it is actually. Oh, I think it might be the Symfony extra credit. It is something that Ryan is going to do, and he has at the moment material for an hour and a half as well. So we sort of discussed splitting that among the two of us. But it's up to you. If you'd like me to continue, I'm happy to continue.
You should ask Ivo to see.
Sorry?
You should ask Ivo to see which room will be available.
That's a good point. Yes, I'll do that. No, that will also be done. But Ryan said he had material for an hour and a half, and it's now listed as 3 hours. So we sort of discussed to split it up. Correct. Because yeah, I am at slide number 73 out of 103. So after aggregation, I have indexes, and I have a little bit about replication. All right, I think you've had enough time to do the averaging here. So what is the operator we're going to use? Group, correct. What are we going to group on? Beer type, correct. Group, okay, I did this wrong. What should this have been? I just mistyped this. Beer type, what should this have been? Sorry? Should be ID, of course. I messed up. It's always going to be ID, because that's the key you're going to group on. And then, what are we going to group on? Which you said correctly was beer type. So which other field I'm going to have in here? Which other fields am I going to have in a group? Average rating? Yeah, that works. Sorry? No, I don't think I need that. Oh, you don't need a count either. Because what you can do here is you can use the average operator And what do I want to take the average of? The rating score. And then it falls off the screen. So I often slightly format this differently. I often do it like this, because it makes it a bit clearer, and it fits better on slides. That should be it. So we're grouping by beer type, and I'm creating the average of the rating score per beer type. And the average rating is, of course, a field that you need to need to specify. So when I run this script, I get PHP not found. Oh, I know what is going wrong here. I made a typo. 99. What the? Oh, see. I missed the square brackets. That usually misses a missing quote somewhere. Oh, that's not handy. Result, right? All right, I'll pass this to less so that you can see. So this is, per each beer type, you're now getting the average rating. Once you have that working, we only want to include the types if there are more than 5 ratings. So now you have the other counters on, yes. So yeah, besides the average rating, you now also will have to have the count. So let's add that. Because we're running out of time, I'm doing this with you. So I want you to shout out what this should be. What is the operator for this? Sum, yes. I know you said it first, but I'd like to hear it from other people as well. And what value would that be?
1.
1, yes. Of course, you can also do 2, if you really want to do that. I mean, the sorting would still be correct, right? But it'd be a bit silly. Okay, so let's see what this does. Does it make any typos? You get also the count, right? So there's count is 5, count is 3, and things like that. So the requirement now said that I only want types, the types that have more than 5 ratings. So what would be my query operation here? Do you hear any other things? No, be match, right? Because we need to filter out things, and that is something you do with match. And match, what are we matching against? We want to make sure that the count is more than 5. So how would I do that? You need to match.
GT.
Sorry? GT. Okay, I said more than 5, not more. Yeah, that's right. And I do that on the count field, right? Which looks at like this. So that would be this requirement. Only include the types if there are more than 5 ratings. Does that make sense? Oh yeah, you're right. Ah, you're paying attention. Good. So how would I do this then? You need to have the field name and then query operation. No? Yes. Sorry, I'm just being silly now. Greater than 5. There. Does this make more sense? The field name that I'm doing the match against is count, and it needs to be more than 5. That's what it says. So when I run this now, you see that I'm only getting the things out where the count is more than 5. Okay. Then there's one more requirement, sort by highest rated type. So which operator am I going to use for that? Sort, yes. And what are we going to sort on? Says so here, says so here. The highest rated average, right? So the field name for that is average rating. And which way are we sorting this? Ascendingly or descendingly? It's 1 or -1. Those are your options.
-1.
You can't have 0, because that wouldn't sort any direction. Should be -1, right? We want the highest rated first. So when we run this, we get still this as results. But it's such a long list, so that is why I have the last requirement only show the top 8. Which would, of course, be... What operator do we use for that? Limit, correct. And then the value, of course, is going to be 8. I say 8, I type 9. That is silly. And then when we run this... Oh, sorry, I forgot the $sign. And then you see which beers I like most. It's Russian Imperial Stout. Why do you think that is? They are dark and they're quite boozy. But I just like the flavor of those more. All right, that's pretty much what I have about aggregation. I know aggregation, to wrap your head around, you need to do lots of practice, and you can do lots and lots of cool stuff with this. I can probably give a 3-hour talk about this, but I don't have more time. Anyway, it's lunchtime now. I suggest I'm continuing after the break. I would expect it to be in this room again, but I'm going to ask Ivo for this. I would expect it because the Symfony Extra credits is also going to be in this room, so I think it will be here. And after lunch, I will talk about indexes, how they work, and a little bit about replication. I don't think I actually have any. I might have one exercise in that. All right. If that's everything, thank you very much. I hope this was useful.